As systems engineering is becoming more model-driven, quantitative methods are really important for effective development.
They give us an opportunity to provide unambiguous evidence for decision making. System engineers are often accused of using checklists and less rigorous techniques. By using quantitative methods, it provides an ability to compare different alternatives on a common basis.
Let's take the domain of energy. Today's energy delivery systems are multimodal. You have solar assets, you have wind assets, you have water assets, but what's the right balance of those in a larger system? So it's through models and quantitative analysis that an engineer could make a decision where you're going to say, I know exactly how I want to allocate my assets across that larger system.
Quantitative methods are very useful in early concept, generation, evaluation, and selection.
Early on, we start to explore how one design relates to another, might conflict with another one. We give consideration to what's really important, when does a product need to go into service, what is the minimum threshold performance level of capability that needs to be inherent in that system. And by trading off between these design options, it allows us to really focus the team on the work ahead and what type of design we ultimately want to pursue.
In trade space exploration, we're really talking about exploring the whole design space. So we're talking about a very large number of design concepts we might be considering. Contrast that with a trade study, where we're really dealing with only a few different alternatives.
In doing our analysis, our trade studies, and looking at the options, we need to make sure that everything works together and is integrated in a table that says, here's option 1, here's option 2, option 3, and understanding from a systems engineering standpoint, how does that affect other subsystems, and what are the pluses and minuses? Because optimizing the complete system is really important.
The utility of these quantitative methods is that it allows system engineers to communicate more clearly to their stakeholders and also revisit decisions that were made. So these quantitative methods provide a traceable means for communicating across disciplinary boundaries. Specialists are very good at thinking about what's best in their domain. For example, a radar expert knows how to design a radar system quite nicely. But if that radar payload needs to share space with a communications payload or an imaging payload on a satellite system, there are trade-offs that necessarily exist. And then when you have these quantitative methods then generating evidence for these trade-offs, you can have a very explicit conversation around how much am I willing to pay, how much complexity am I willing to add, how much of my mission am I willing to sacrifice when trying to make a system satisfy these quantitatively derived needs.
We know that the world keeps changing and our engineering practices change. Our methods need to evolve as well. So we can think of these quantitative methods as kind of the current baseline on which we can build, and we can find even better ways to improve the effectiveness of our engineering.